So in this video, we will look into the next factor of that is g of s is equal to s. So in the Bode plot in root locus, we had seen that whenever we plot a Bode plot or the root locus for any function, the reciprocal when you take the reciprocal of that function, the Bode plot or the root locus plot would be simply the mirror image of the original function. That was the case in case of Bode and root locus. Whereas in case of Nyquist plot or the polar plot, it is not like that. So you cannot say that S will be just the mirror image of 1 by S. So we'll see why. Okay, so first I'll take g of j omega is equal to S. Sorry, is equal to j omega. So I'll write this in a complex form, that is 0 plus j omega. This is the term, and when you take this is the rectangular part, polar form will be omega at an angle 90 degree. Okay, so similar to the above function, I'll just tabulate for omega equal to 0 and infinity. So real part of g of j omega, then imaginary part of g of j omega, then magnitude of g of j omega, and angle of g of j omega. First, omega tends to 0 and omega tends to infinity. So these are the things that we are gonna plot. Right. So now when omega tends to 0, we can see that the real part will always remain 0. It is not dependent on omega. So this will become 0 and 0. Coming to the imaginary part, when omega is 0, imaginary part is 0 and this is infinity. Again, coming to the angle, it is irrespective of omega. So this will remain 90 degrees and 90 degrees. Magnitude, this is 0 and this is infinity. This is very simple. So similar to the above observation that we've made. So as we move or as we vary omega from 0 to infinity, the imaginary part of j omega will always be positive. Will always be positive, and real part of j omega will always be 0 or constant. So the real part is 0, which means that again the g of s plane is not it is on the imaginary axis. Okay, so it is on the imaginary axis. Use a different color. This is real, imaginary. This is 0. So this is my g of s plane. So first point is when this point is nothing but 0 comma 0. This point is nothing but 0 comma infinity. Okay, so here I'll take this extreme as plus j infinity, this extreme as minus j infinity. So this will always remain on this plane, this plot only. When you plot vary 0 to infinity, this is your first point. This is your second point. This is for omega tends to 0, and this is for omega tends to infinity. So just join these 2 points and your direction is in this way direction. Okay, so you can see that the direction as even though it will look like a mirror image, look at the direction. It is not towards 0. It is away from the 0. So it is not exactly the mirror image of the above function. Here it may look like a mirror image, but look at the direction. In previous case, the direction was towards 0, but here the direction is towards infinity. So the plot is not the mirror image of the above plot. Fine, though it may look like it, but it is not. Okay, based on the direction, you need to make it out. Fine, so this is the polar plot of g of s is equal to s. So now we'll see in the next function, that is g of s is equal to 1 divided by ts plus 1. So g of j omega will be equal to 1 divided by 1 plus jt omega. Fine, so I'll just rationalize this function. The reason why I'm rationalizing this function is only to separate the real and imaginary part. So 1 divided by 1 plus j t omega into 1 minus j t omega, 1 minus j t omega. So this is equal to 1 minus j t omega divided by, this is nothing but 1, that is 1 plus t square omega. So this is the function. I'll just write it as g of j omega is equal to 1 divided by 1 plus t square omega square minus j into t of omega divided by 1 plus t square omega square. So this is your real part. This is the real part of g of j omega. Okay, I'll make a small change here, not a change. I'll make it plus and this is minus. That's it. Okay, so the imaginary part is this. This is your imaginary part of g of j omega. Okay, so the magnitude of g of j omega is equal to 1 divided by root of 1 plus t square into omega square. So you can take it from this expression only. You don't have to verify the from the this expression. From this expression, you don't have to verify it. From this expression itself, you can write that the magnitude is equal to 1 divided by root of 1 plus t square omega square, and angle of g of j omega is equal to the angle of this is 0 minus tan inverse of omega t divided by 1. So most of y'all are like, you all take it as omega t divided by 0 and you all make it as infinity, but it is omega t, tan inverse of omega t by 1. So I can write it as minus tan inverse of omega t. So this is the um, real part, this is the imaginary part. Similarly, as in case of the previous case, we will tabulate it. So omega, real part of g of j omega, imaginary part of g of j omega, magnitude of g of j omega, and angle of g of j omega. So now here we will vary omega from 0 to infinity. But now we will have one more case, that is when omega is equal to 0. When omega is equal to 1 by t, we will take this cutoff frequency also. And when omega equal to infinity. So always remember that one case, t is always greater than 0. It's a positive number. That is the assumption we make here. T greater than 0 will simply mean that we have only right hand side poles. Fine. So this is 1 by t. Now as omega tends to 0 and omega tends to infinity, we will just simply plot it. So when omega is equal to 0, what is the real part? The real part is this is 0. See, when omega tends to 0, you can see, look at the real part of this. When omega is tending to 0, this second term is much smaller compared to the first term. So your 1 is like omega is very small compared to 1. So we will ignore this term. So what remains is 1 by 1, which is equal to 1. I'll repeat again. When omega is 0, omega is a very small value. T into omega, t square into omega square will be much smaller value. So your t omega will be very small compared to 1. So when that is the case, this second term will be ignored. What remains is only 1. 1 by 1 will be 1. So that is the first case. Coming to the imaginary part, again, in the denominator, this will become 1. Whereas in case of numerator, t into omega, omega is tending to 0. So this will tend somewhere to minus 0. The minus 0 representation doesn't have to do anything with the actual value. It means that it is approaching 0 from the negative side. Okay, from the negative side, it is approaching 0. That is the meaning of minus 0 that I have put here. Coming to the magnitude of this, same thing. T square omega square will be very small compared to 1. So this is nothing but 1. So obviously 1 and 0 magnitude is 1. So don't take it as 1 and minus 0. It is 1 and 0 only. The only reason why I am putting it minus 1 is minus 0 is it means it is approaching 0 from the negative side. Okay, that is the meaning of minus here. It is not the actual magnitude. We are not depicting 0 as a negative number. It only means that we are approaching 0 from the negative side. That's it. Okay, and angle. Yeah. Now angle, coming to this, tan inverse like omega is approaching 0. So omega t will approach 0. So minus tan inverse of 0 is nothing but 0 degree. Tan inverse 0 is 0 degree. Okay, so this is the first case. Second case is 1 by t. So 1 by t, put 1 by t here. So this is 1 by 2. When you put 1 by t here, this becomes 1. This entire t omega will be equal to 1. So t into omega will be equal to 1. So when that is the case, the real part is 1 by 2. Similarly, the imaginary part will be 1 by 2 and the magnitude will be 1 divided by root 2. Coming to the angle, it is minus tan inverse 1. Minus tan inverse 1 is nothing but minus 45 degree. Next, omega is tending to infinity. Now, when omega tends to infinity, coming to the real part, your 1 will be very small compared to this because t square omega square is infinity. So this is 1 by infinity, nothing but 0. Similarly, here it is uh, again it is 1 by, you get across, you would neglect one term. This term will be neglected. Minus t omega divided by t square omega square, which will be equal to minus 1 by t omega. Fine. So like if you put for this limit omega tends to infinity, so this becomes minus t omega divided by, coming to 1 plus t square omega square. 1 is very small compared to t omega. So 1 is very small compared to t omega. So what remains is only t square omega square. So I have minus 1 by t omega. So when omega tends to infinity, this will be equal to 0. Okay, it is equal to minus 0. The reason why I am taking it minus 0 only because to indicate that it is becoming 0 from a negative side. It is approaching 0 from a negative side. This becomes minus 0. I'll just write it as only 0. We'll see later how we take it. Okay. Now coming to the magnitude of this. Magnitude is again root of 1 divided by 1 plus t square omega square. So again it is 0. Both terms are 0. So obviously this will be 0. Coming to the angle minus tan inverse infinity. Tan inverse infinity is 90 degree minus tan inverse infinity is minus 90 degree. So this is the tabulated column. So now we will plot this on the G of S plane. This is real part. This is the imaginary part. Now in the previous case we have taken 2 points. We have tabulated 2 points. Now here we have 3 points. Okay. So I'll just write one by one which are the points. So this is nothing but 1 comma 0. This is 1 by 2 comma 1 by 2 point. This is again 0 comma 0. Okay, so now we will plot this here. So first one will be 1 comma 0. So this is 1. So this is 1. So your first point is this 1 comma 0. Second it is 1 by 2. This is the second point which is 1 by 2 comma 1 by 2 point. So even this is minus j 1 by 2. Yeah, this is minus 1 by 2. Make a small correction here. This has to be minus 1 by 2 because we have a minus sign. So this is minus j1. This is 1 by 2. This point is minus. This is minus. So we have this is 1 by 2 comma minus 1 by 2 is the point. So this is where it is. Now you need to plot these 3 points. So this is your third point which is 0 comma 0. So this is when omega tends to 0 and this point is when omega tends to infinity. This is when omega is equal to 1 by t. Now coming to these 3 points, the possible way is to plot it like this, but we don't plot it like a straight line. We use the smooth curve. We have to use the smooth curve. Okay, so the smooth curve will look something like this. That is a semicircle which is having center at 1 by 2. So this is how your your polar plot will look. The direction is from omega is equal to 0 to infinity. So this is the direction of the polar plot. This is how the polar plot for this function will be drawn. So always we don't draw the exact linear curve, we draw the smooth curve. So when you take different points, this is how it will look like. You take different omega values like from omega equal to 1, 2, 3. So this is how the plot will look like. A smooth. This is a semicircle in nature. Semicircle in nature. That is the polar plot of 1 divided by ts plus 1. In the next video, we will look into much more functions.